Hello, algebra students. Today I am going to take you through the 4-2 practice quiz in preparation for your quiz on either Thursday or Friday, depending on whether or not you are an A-day or B-day student. Okay, so problem number 1. Use substitution to determine the solution of the system of equations. So the first thing I notice is that this problem is actually set up perfectly for substitution because I have x equals 3y plus 4. So I'm going to take that 3y plus 4 and I'm going to substitute it in for x into my second equation. So if I were to do that, I take my second equation, which is the 3x minus 5y is equal to 8. And instead of x, I'm going to substitute in 3y plus 4. So I have 3 times 3y plus 4 minus the 5y equals 8. From here, I'm going to use the distributive property. So 3 times 3y is 9y. 3 times 4 is 12. And I have minus 5y is equal to 8. From here, I'm going to combine my like terms. So I have 9y minus 5y, which is 4y, plus 12 is equal to 8. I'm going to subtract 12 from both sides, and I end up with 4y is equal to negative 4. And a last step is to divide both sides by 4, and I get y is equal to negative 1. So I just figured out what y is, but in order to figure out what x is, I now need to substitute y equals negative 1 into one of the two equations. The easiest equation is the top equation. So I have x equals 3y plus 4. Remember, if I'm trying to figure out what x is, that would definitely be the easiest equation because I substitute in for y and get my x value. So I'm going to have x equals 3 times negative 1 plus 4. So I have x equals negative 3 plus 4, and then that last step would give me x is equal to 1. So my solution here would be as written as a point xy would be 1, negative 1. So my solution here is D. D is the correct answer. Okay, let's go to problem 2. So problem 2, again, use substitution to determine the solution of the system of equations and write the solution as an ordered pair. So again, I see that this problem is set up very nicely for me to do substitution. Why? Because the second equation has a variable equals an expression. So y is equal to this negative 5x minus 17. I'm going to take that expression and I'm going to plug it into the y in my top equation. So if I do that, I'm going to start with my top equation, which is negative 3x minus 3y equals 3. And again, I'm going to substitute in for y that expression of negative 5x minus 17. So I have negative 3x minus 3 times whatever y is. So again, I'm going to use parentheses here and make sure you're careful with your signs. Minus 5x minus 17. And then I still have equals 3. From here, I use the distributive property. So I have negative 3x. Negative 3 times negative 5x is going to give me positive 15x. And then negative 3 times negative 17 is going to give me a positive 51. And that equals 3. I'm going to combine my like terms of negative 3x and positive 15x. So I have 12x plus 51 is equal to 3. From here, I'm going to subtract 51 from both sides. So I have 12x is equal to negative 48. And then my last step is to divide by 12. And I end up with x is equal to negative 4. Again, you have to be careful with your signs. All right, I still need to figure out what my y value is. So the easiest equation is the bottom equation because I have y equals negative 5x minus 17. And if I just substitute in for x, I'm going to figure out what y is. So I'm going to substitute in -4 for x. So I have y equals -5 times -4 minus 17. Well, -5 times -4 is +20 minus 17. So y is equal to 3. So my solution, written as an ordered pair, my x value is -4 and my y value is 3. So I have the point -4, 3. Okay, let's go to problem 3. So problem 3, which system is represented by the graph? So the first thing that you should notice is that these two lines are parallel. And if these two lines are parallel, and I'll write that here for us just to remind us, if the two lines are parallel, that means that they have the same slope. So if these two lines have the same slope, I'm going to look at all of these systems of equations, and I'm going to see which set of system of equations actually has the same slope. You have many ways that you could do that. If you want to write all of the equations in standard form, you'll be able to see what the slope is by using standard form. Remember, that's the slope would be the opposite of a over b. But I do know that many of you like to change these equations into slope-intercept form. So that's how I'm actually going to solve these, just so I can kind of do what most of you do. Okay, so I have 2x for A, solution A. I have 2x minus y is equal to 3. Well, if I subtract 2 x's from both sides, I end up with -y equals -2x plus 3. I know that if I want it to be written in slope-intercept form, I have to have a positive y. So I'm going to multiply this entire equation by -1. And that will give me y is equal to a positive 2x minus 3. If I look at the second equation, I have 2y equals -x plus 3. So I need to solve for y here. So I'm going to divide every single term by 2. And I would have y equals -1/2 x plus 3/2. Well, if I look at the slope of those two equations, the slope of the first equation in A is 2. The slope of the second equation in A is -1/2. That is not the same slope, so it cannot be A. All right, so let's move on to B. So in problem B, I have 3y equals -2x plus 5. To get it into slope-intercept form, I'm going to divide every term by 3. So I will end up with y is equal to -2/3 x plus 5/3. So in that equation, my slope would be -2/3. So now I have the second equation, which is 6x plus 9y equals 1. Again, you could find the slope because that's in standard form. It is the opposite of a over b. But again, for those of you that like to put it in slope-intercept form, I'll do that right now. So you subtract 6 x's from both sides. You end up with 9y is equal to -6x plus 1. From here, you need to divide every term by 9. And you'll have y is equal to -6/9 x plus 1/9. -6/9 here, if I were to simplify that fraction, is -2/3. Looks like we have the same slope here, and we have a different y-intercept. So it looks like B is going to be my solution. We'll double check because we'll do C and D. I'm actually going to erase this work. I'm sorry, but I don't have any other room to do that. So I'm going to erase all this. So I'm assuming that my solution is going to be B, but let's check C and D as well. All right, so solution C, I have x minus y is equal to 10. And if I solve for y, I will have to subtract x on both sides. So I will have -y is equal to -x plus 10. And then we know when we want this in slope-intercept form, I need to multiply the entire equation by -1. So my equation written in slope-intercept form is y equals positive x minus 10. So that's my first equation. If I look at the bottom equation, it's actually already written in slope-intercept form. So my slope for this equation would be -1 because it's a negative x and the number in front of x would be the -1. My slope in this first equation is +1. Not the same slope. That means that the lines are not parallel, so the answer cannot be C. All right, and again, we're just checking, so let's do D as well to make sure. So in D, the first equation is already set up nicely for us in slope-intercept form. I can see that my slope is 3. So I just need to change around the second equation. So I have 4x plus y is equal to 2. I would subtract 4 x's from both sides. So my equation would be y is equal to -4x plus 2. As you can see, my slope here is -4. And if I compare the two slopes, 3 and -4, not the same slope. So that means that those two equations are not parallel either. So the only system of equations that has the same slope was B. And again, that means that if they have the same slope, it's parallel. All right, moving on to number 4. So problem 4, they have two parts here. So the problem, Brenda's school is selling tickets to a spring musical. On the first day of ticket sales, the school sold 9 adult tickets and 3 child tickets for a total of $75. The school took in $60 on the second day by selling 8 adult tickets and 1 child ticket. Choose the system of equations that models the situation. All right. So I know from my first sentence, let me use my highlighter here. I know on the first day, the school sold 9 adult tickets and 3 child tickets for a total of $75. So if I thought about this, and you can see in the answers, the A, B, and C possible solutions, they're using A to account for the cost of an adult ticket, and C is going to represent the cost of a child's ticket. I'm actually going to write that down for you. So we're going to let A represent or equal the cost, or I'm going to put, just for you for right now, I'm going to put a $sign. So the cost of 1 adult ticket. And then C is going to be the cost of 1 child ticket. Okay? So if I have 9 adult tickets and 3 child's tickets for $75, I can come up with the equation that 9 adults tickets, so 9 times the cost of an adult ticket, plus 3 times the cost of a child ticket should give me $75. If I look at my possible answers, I only see one. Looks like B. All right, but let's check it out with the second portion of this. So they tell us in the next sentence that the school took in $60 on the second day by selling 8 adult tickets and 1 child ticket. All right, so if I was going to come up with that equation, I know that they sold 8 adult tickets, so 8 times the cost of an adult ticket, and 1 child ticket, so plus 1C, and that's going to be equal to 60. Well, as you can see, the answer has to be B. Those are the two equations that work. That's the same two equations that I already have written down. All right, so for part B, we have to use that system of equations to find the cost of each adult ticket and each child ticket. All right, I'm going to erase my 2 equations here. I'm just going to use the 2 equations that I have in the answer. All right, well, before I can solve this, and again, we're going to use substitution, before I can solve this, I need to take the bottom equation and I'm going to solve for C because I need to solve for a variable in order to use the substitution method. So I have 8a plus c is equal to 60. I would need to subtract 8a from both sides, and I would have c is equal to, and you could have negative 8a plus 60. I'm just going to put 60 minus 8a. Either way you write it would be fine. All right, so now that I've done that part, I know that c is equal to the 60 minus 8a. I'm going to take that and I'm going to substitute it into the top equation in for c. So if I write my top equation, I have 9a plus 3c is equal to 75. I'm going to substitute in for c the 60 minus 8a. So I have 9a plus 3 times, make sure you're putting this in the parentheses, 60 minus 8a, and that's going to be equal to 75. From here, I just need to do the math. So I have 9a, use a distributive property, 3 times 60 is 180. And then 3 times negative 8a, be careful, watch your signs, is minus 24a, and that equals 75. From here, I'm going to combine my like terms. I have 9a and negative 24a, and together that would give me a negative 15a plus the 180 is equal to 75. My next step would be to subtract 180 from both sides. And that would leave me with negative 15a is equal to 75 minus 180. I think it's negative 105. I don't have a calculator right here with me, sorry. And then the last step would be to divide by negative 15 on both sides. And if I have negative 105 divided by negative 15, I believe the answer is positive 7. So A would be equal to 7. All right, so that would be the cost of a one adult ticket, since again, where am I getting that from? What I represented up here, okay? So A is equal to 7. The last thing I need to do is figure out what the cost of a child's ticket is. So I need to go back and plug in my value for A into one of the two equations. I'm going to erase what I did here just to give myself a little bit of room. I'm going to put the solution for the A into the bottom equation just because less multiplying. Honestly, that's probably the only reason why I'm choosing that particular equation. So I have 8a plus c is equal to 60. I'm going to substitute in 7 for a. So I have 8 times 7 plus c is equal to 60. If I multiply 8 times 7, I end up with 56 plus c is equal to 60. Subtract 56 from both sides, and we get c is equal to 4. So that means the cost of one child's ticket is 4. You can take my word for it, or you can actually go back and do the check. If you do the check, remember you would replace the a in the both equations. Sorry, I'm trying to erase this. You would replace the a in both equations with 7 and the c in both equations with 4 and make sure that both sides equal. Okay? All right, last but certainly not least, problem number 5. Choose the correct words from the drop-down menu to make the statement, to make a true statement. So you have the two equations, 9x plus 3y equals negative 15, and y is equal to negative 3x minus 5. As you can see, this particular system of equations is set up perfectly for substitution because you have the variable y is equal to this expression, negative 3x minus 5. So I'm going to take that expression and I'm going to substitute it into y in that top equation. So let me jump back to another color. So I'm taking the equation 9x plus 3y is equal to negative 15. And I'm going to substitute in for y the negative 3x minus 5. So I have 9x plus 3 times negative 3x minus 5. Make sure that that's in parentheses. And then that's going to be equal to negative 15. From here, we're going to do the math. So I have 9x. 3 times negative 3x is minus 9x. And then 3 times negative 5 is negative 15. Again, make sure you watch your signs. And that's equal to negative 15. Well, from here, you should see that 9x minus 9x, that would cancel. That leaves you with 0. So since that's going to cancel out, you're left with negative 15 is equal to negative 15. And I believe that that is true, that negative 15 does equal negative 15. Since that's a true statement, it means that it has infinitely many solutions. So that is the correct answer. Remember, if this had been, so just, in case you see something like this on the quiz on Thursday or Friday, if you had gotten something that looked like this instead, 10 is equal to negative 15, something that wasn't true, remember that that would be no solution. Okay, but in this problem, once we worked it out, we figured out that negative 15 equals negative 15. That is a true statement, so it means that there's infinitely many solutions. Okay, guys, that takes care of going through this entire quiz. If you have any questions, please don't hesitate to reach out to your math teacher. Have a great day.